All right, all right. Welcome to Tech Tuesday. And you are in for a treat. I am going to go over some code today. All right. I want to do some code review, and it's involving um for finding primes. So I'm going to share my screen right and let you on the process. Okay. All right. So I'm going to kind of detach this right here. Okay. Let's see. I got to make sure. Okay. It says that I am streaming right now. You can see the code. So the very first thing code is import math because we're going to be utilizing the square root function that's inside of the math library. So line number 4 basically imports the math library so that we can use that function. So we didn't actually have to create that function ourselves. We just have to use it from what was already created in math library file. Okay. So let's see. I think that's the only other math. That's the only math that we have in there. The other ones are just already part of the Python editor. For example, the percent symbol is a modulus operator. So it's not from the actual math library. It's just something that's already known as the operator um, for doing certain math operations. Okay, so if you look at line 6, you'll see the definition of is prime. It's a function that is user defined. So that means I created it so that it could be used by the program later on. So as you can see at the very end of it, it's saying that a boolean is returned. That's what that slash greater than symbol or the arrow bool, it means boolean. So we're gonna have the boolean as the return value for this definition. Okay, so after the function does what it does, it's going to return true or false, prime, right? So that's what we want to know. Is it prime? And then there's certain condition statements within the definition that determines whether it's going to return true or whether it's going to turn false. So let's look at it. Let's look at 7, line 7, where it says if n, that's the number or the integer that is brought into the function when it's called, and there's a check to see if it's less than or equal to 1, then we're going to return false. For sure, we know that it's not prime. If n is 2, 3, or 5, then it's going to return true. It is prime. If n, the number that's brought in, is divisible by 2, 3, or 5, then we can immediately return false. So if it's a multiple, that means it's going to be divisible. Okay, so what line number 12 does is check to see, is it divisible by 2 or divisible by 3 or divisible by 5. And if it is, then we're going to return false because that means it's not prime. Okay, so any multiple of 5, we can quickly determine that it's not prime. All right, then line 16 is a test for potential prime divisors of the form 6k plus or minus 1. So that basically means, we're going to check to see if it ends in 1, 3, 7, or 9. Yeah, we're going to go back and forth between the step being, like divisible by one of those numbers or ending in 7, 11, 13. I mean, just it's ending in the way we want it to end so that we can determine if it's prime. All right, so while D is less than the limit, so the limit is basically like determined on line 16. That's the one where it says square root of n. So the reason why we choose square root of n is because we don't need to check all the numbers and we have to go all the way to n or up to n to find out if it's prime. We just have to check, the numbers less than square root of n. And that's a shortcut so that we don't end up overloading the processor and doing unnecessary for divisibility. Okay, so modulus equals 0. That's a crucial divisibility check. So basically it's saying if the remainder is 0 when you divide n and d, that means it's divisible, and we return false, meaning that it's not prime. If it's divisible, that means it's a multiple. Okay. Um Turn true. Okay, if it does all that and we check all the possible divisibilities and we find out that it is not divisible by anything less than square root of n, then we can return true. Okay. All right, so that being said, we can go ahead and run this and see how it's gonna go. Okay, so here I am going to press the run button. I had already pressed it and I stopped it, but now here I pressed run again and it says enter the starting range. So this time I'm going to put 100. We'll start at 100 and we're going to end at 200. So we just want to know what are the prime numbers between 100 and 200. Okay. And so it should give us a list of those prime numbers. Isn't that cool? Without having to start over from scratch, we can go from 100 to 200 and find out what prime numbers are in that range. Okay. So we don't necessarily have to overload the system. We can just get specific ones if we want to. We could even do even like, a smaller range. Instead of 100, we could do a range of 50, or we could do 25, or even 10, or even 2, right? To see if it's prime. All right. You can let me know what your questions are in the comments, or just like this video and let me know what other type of demonstrations you want to see, I can do projects that relate to what you want to do. I just like math, so I do a lot of math, you know, based questions and algorithms. If you look down a little further, um, down the line, you see how it's limited to just 1, 2, 3, 4, 5, 6, 7. I think it's just a 21, I want to say. Yeah, 21 prime numbers between 100 and 200. Okay. So this is a quick, fast way to determine primes within a range. So let's do another. Let's see. I think I saw somebody say hello. Hi. Ah, I like that name because Joseph is my last name too. So hi, Joshua Joseph. So then we're gonna go and do another trial run. This time I'm gonna do like a bigger number and see how many primes we're gonna find. Maybe between 1,000 and 1,100. Let's do that. It's still a range of 100, but we're gonna see which ones are prime. See, the list is short and it's not that hard to see that the prime numbers end in 1, 3, 7, or 9. So um notice the similarity in the ending numbers. They're all ending in 1, 3, 7, or 9. That's not by coincidence because prime numbers are usually odd numbers, except for the number 2. And after 5, the very first 5, any multiple of 5 is definitely going to be composite. So it's not going to appear in any of the prime numbers after. So yeah, a prime number is never going to end in 5 except for 5. So we'll just see that all of the prime numbers are going to end in 1, 3, 7, or 9. So we can kind of figure out the probability that a number is prime, right? What are your chances that you choose or you predict a number is prime or not? That's a good question, right? Can see if you can answer in the chat. What's the probability that a given number is prime? Well, we know it's going to be less than 30%. How do we know? Okay, we know that because, okay, I'm sorry, all the numbers that are even, that's half, right? That's half the numbers right there. And then you have numbers that end in 5. That's another, especially like in a set of 10, I mean, set of 100. In a set of 100 numbers, all 10% is going to end in 5, right? And um, so we can kind of take away another 10% from the 50%. So that's 60% right there. 60% of the numbers are going to be composite. And then after that, um, we still have the ones that are multiples of the numbers less than square root of 10, even though they're odd. So some of the odd composites are multiples of previous primes. So that's pretty much what we want to determine, which ones do not divide by other previous primes. So that is what this algorithm does. All right, so you don't actually necessarily have to figure it out, but you can determine it just by putting in the range. What if I put in the range of 10? Let's see what it's going to give. So if I said and 1010, then that's just, oh, it's just one number. There's only one prime number, and that's 1009. Okay, so let's see. Is that right? Let's run it again, but this time we're going to do 1000 and 1000. Hold on. Oh no, that's not what I meant to do. Did I put 10,000? Oh no. Okay, let me try this again. So I'm gonna put 1000 and 1100. That's what I meant to do. Okay, so notice it starts with 1009. So yeah, there's only one between 1000 and 1010. So yeah, that's so. Thank you so much for tuning in to this um Tech Tuesday. Let me know what you want me to cover in the next one. We can do any project you like. Um, I know in the Python code course we have the basic calculator where we use the Tkinter module. So if you'd like to see that, let me also know. If you're watching in a chat replay, I mean, sorry, you're watching on the replay. Just let me know in the chat or in the comments that you want me to cover the first project in Python code course. And I can do that on Tech Tuesday. Until next time, I'll see you later. Bye for now.